So, we have turned tables and points and mappings. We have determined if those things are functions or not. The only thing we haven't looked at is we need to be able to look at a graph and determine, hey, is this just a relation or is it a function? We've done tables, we did points, we did mappings, we did all of that yesterday. The last thing we have is we need to figure out how do we look at a graph and tell if it's a function. And there's a little math test called the vertical line test. And in math, vertical means up and down. If you're a basketball player, you definitely know what the word vertical means, right? Okay, if your goal is to have the largest vertical you can have, okay, how high you can jump. So, a really good way to do this is you take your pencil, you have it straight up and down, and you'll put it on your piece of paper. That's going to be your vertical line. And you're trying to figure out how many times at a given point will my pencil, my vertical line, hit my graph. If your pencil, when you slide it across your paper, hits only one time, it's a function. If it hits more than one time, when you have it laying on your paper, then it's not a function. Because if your pencil hits twice or 3 times or 4 times, that means you have more than one output, which is not allowed for functions. So we're going to take a look at this. Now, I don't have a pencil, but I do have a little line. So I'm going to lay my pencil, which is a line for me, on my paper. So take your pencil and just lay it on your paper vertical, like this.
To match up with the line straight up and down.
Okay. Now you're going to take your line, and usually a good place to put it is just put it right in the middle of your graph. So it's kind of cutting it in half. Right now, your pencil is hitting our red line how many times? It's only hitting, see how it hits right there? So it's only hitting 1 time. Now you should check a couple spots. Let's say I put it a little bit to the right. How many times is it hitting? Just 1 time. Let me try this side. How many times does this hit? Once. Okay? Will my line ever hit twice at the same time? No matter where I put it? No. So this passes the vertical line test. So this is a function. Function. Your reasoning is because it passed the VLT. Passed the vertical line test, VLT. Now let's go on to our circle over here. Circles are the bane of algebra's existence, and here's why. If I take my pencil and I lay it in the middle of my page, yikes, what's happening? It hits twice. Okay? And hitting twice in algebra means there's 2 outputs. At 0, we would hit 3 and -3. It has 2 outputs. And can function have 2 outputs? So automatically this fails the VLT, the vertical line test, so it is not a function. Okay, so this is not a function. Okay, you try the last 2 on that page. Not a function! Sad day.
And so that's 2 touch lines.
Okay, so you're working on these 2. Yep. Very good, very good. Love the reasoning, Darren. Perfect.
Guys, here's a clue. If you have a straight line as a function, unless it's directly straight up and down, which is another vertical line, it's always going to be a function.
Parabola. We will do parabolas in here. Give it time, yeah. first one.
What
you
do
think?
guys? How many people think it is a function? Raise your hand. How many times,
Here, you fill it up.
if you cross
I got some.
that shape, will it hit? Doesn't matter where you put it in that shape, it's gonna hit it 2 times.
Yes, sir.
So that means it is what? Not a function.
Uh-uh.
Everybody getting the vertical line test? Pretty straightforward.
Straight up and down.
Yeah.
How about that second one? Is this a function? Yeah, this is a function. No matter where my line is, if I slowly drag it across, I'm only ever hitting my red line just one time. So this is a function. Yeah, it's stamped on the bottom. You can go.
Yeah, what did this call you? That what the lines that you
A cubic.
do.
We don't do cubics in here. Not till algebra 2. We do parabolas like this example up here. Alright.
Yeah.
Now we go into the fun ones. Flip the page. These are the fun ones.
Put your thinking caps on.
Now I know the printer sucks a little bit, so yours might be a little harder to see.
You guys can use any straight edge. Pencil's probably easier.
But upon first inspection, why are these ones a little bit different? There's multiple lines, and looking at the ends of the lines, what do they have? Some of them have, but in math we call those circles what? Yeah, we have open points and we have closed points. So that's something we have to pay special attention to. Okay? We have to pay special attention to. So I'm going to make my line here. Okay?
You do that really straight.
It does it for me. So in math, we have to remember a hole means we fall through and it doesn't count. So if I put my line right here, see how it hits a point? See how it hits that point with an open circle here? So an open circle means we fall through and die. Okay, it's a hole. It doesn't count as hitting the graph. Okay, now when we are on a solid point, that counts as hitting our graph. So if I put my line right here, does that hit the graph? No. If I put my line right here, is it hitting the graph? Yes. Open circles, we miss. We're not hitting the graph. We missed. We fell through the hole and died. If we're hitting a filled in, a solid point, that counts as hitting the graph. So maybe off to the side, open circle, closed circle.
You guys remember when we were graphing, open means it doesn't include that value. So you're not actually hitting a point. It's gotta be solid.
Okay, so if we're doing this first problem, remember our rule for a function is every input has to have one output. Now, I think there's one spot that's obvious on this. On this graph, what's one reason why this might not be a function? Because it what? Yeah, if I put my vertical line right here in the middle, what's it doing? It's hitting it 2 times, and these are closed circles, so it counts as hitting. It hits here, and it hits there. So, we already know this graph is not a function. There's one other spot where this graph fails. That spot is right here. Why is it failing here?
Because it's not hitting the graph.
It's not hitting the graph. This means when we input the point -2, I hit a hole. This means I'm not hitting the graph. And hitting the graph a bunch of times fails, but also not hitting the graph at all will make it fail. So here we are also failing, so it kind of fails twice. This is not a function. Because we fail the VLT. We fail the vertical line test. Yeah. Okay, take a look at our second one. Tricky with holes. Tricky. Okay, here we go. So I'm starting to do my vertical line test, right? I start moving myself to the side. As I slide this apart, I'm like, okay, look, how many times is it hitting? Once, boop, what happens here? It's going through how many holes? Two holes, right? So because we're going through two different holes, the question is, does this count? Right? If I put -1 into this function, does it have an output? No. But let's keep going. What about right here? Is this okay? Yeah, it's missing this hole, but what does it do down here? It hits. So right there is actually okay. However, we do have a hole in our function, and now this is where you're going to get a little annoyed. So there is a difference between, and this is why I put this example, there's a difference between this hole and this hole. Okay? And here's why. Here, we have an input. Our input is -2, right? But we have nothing there. Here, because both parts of our graph don't exist, there's just a hole in the function, which is okay. Does that make sense? Kind of. Do you see how we have, I know, I don't like, this is what makes this is the hardest part. So, nothing exists down this line, right? Neither graph is touching there, okay? And because neither the graph isn't touching either the top or the bottom, this is just a hole in the graph. It doesn't mean it doesn't have an output because there is no input. Here we do have an input of -2 with a hole. Here we don't even have any, -1 can't be put into our graph because both pieces of the graph have a hole. So this is a function, okay? Because nowhere am I hitting more than once. Does that make sense? Kinda? We'll do more. So this is a function. Okay. Let's do 2 more, and then we're done. Okay, try this one. Squiggly, it's a sine wave. How many times does your line hit your sine wave? Fourth, fifth, or after school?
Sound waves don't travel as fast as light waves. That's why a lot of times you guys see the lightning before you hear it.
What? I know, but like you said, plus you gotta so this is a function. Very good. This is a function. Now look at this crazy boy. This is called a piecewise function because it's made up of lots of pieces. So look, we'll just go part by part. Right here, how many times do I hit? Once, because solid point, hole. Right here, how many times do I hit? Once. Everywhere I hit only once, because one's a solid point, one is a hole. Now, so this is a function. Now, if I were to fill in one of these holes, now it would not be a function. Okay, but because one of the points is a hole and one is a solid point, it's only hitting the graph one time. Does that make sense? No? Yes? So this is a function. Function! Yay!